Hey guys, coming to you outside today for a little bit of a change of scenery here. It is a wonderful day. Hopefully you guys have the opportunity to get outside a lot too. It definitely helps to mix things up. And today I'm going to teach you a little bit about and probability. So to get things started here, I have an example of a sort of problem that you see a lot on like the ACT and stuff like that. So when this quarantine finally ends and I'm back in school, I'm going to look through my wardrobe right here, and I have five sweet teaching shirts going on over here. And I have three pairs of pants, all of varying colors. And I want to know how many outfits I can make where I grab a shirt and I put it with a pair of pants. Like I said, the ACT likes to do this sort of problem quite a bit. So this is a good topic to be familiar with for that situation. One way to do this problem is to simply make a list of all the options. So what I did is I labeled my shirts A, B, C, D, E. My pants are 1, 2, 3. And down here, what I did is I listed out every possible combination I could do. So I could wear shirt A with pants 1, 2, or 3, shirt B, pants 1, 2, 3, and so on. And you just count up the possibilities. All the possibilities for a problem is called the sample space. So I basically wrote out my entire sample space and I saw that there were 15. Now let's say I took this same problem, but I realized, oh my gosh, I don't just wear a shirt and pants. I also need to have a pair of shoes. And I had two sweet pairs of shoes here, my awesome teal shoes, and then I would have my awesome longer pair of teal shoes right here. So if I was going to do my two pairs of shoes, I already took the time to write out, let's say this is pair Y and this is pair Z. I could take this exact same list and put shoes Y with all of them, or I could write that whole same list a second time, but this time I could wear that list with Z, shoe Z. That would be a total of 30 possibilities then instead of just 15. So it looks like a nice shortcut for what you can do, and this is actually a really famous math result called the basic principle of counting. Again, appears on the ACT all the time. All you're going to do is take the number of options for each one. So I have 5 options for shirts, times I have 3 options for pants, times 2 for shoes, and I get 30 possibilities. So you just take how many possibilities for each one, and you multiply them together. That tells you your total options. So let's take that idea and apply it to a new problem here about people. So I've got 6 people conveniently with names starting with A, B, C, D, E, F, and I want to know how many different ways these 6 people can get into a line. So if you think about writing these all out again, that was great with my nice small shirts problem where I didn't have that many possibilities, but man, there's going to be lots and lots of ways I could line up these 6 people. I started doing it right here, but with all of those options, I didn't even change the first 3. So I was just mixing up the back 3 people, and there would be so many options, because think about like having B in front, or C in front, or D. It's just crazy. So making a list isn't always going to be feasible or easy to do. So what you can do instead, think about it like the shirts and the pants. When I'm going to pick who's going to go first in my line, just like I had 5 shirts to choose from, I have 6 people to choose from. So I'm going to have 6 possibilities for who goes first in my line of people. Well, then I go and I say, okay, who's going to go second in my line? Well, now, say I chose this person, doesn't really matter who I choose. I chose one of them already, so I'm only going to have 5 choices left for my second spot in line. So my second spot is only going to have 5 possibilities because I've already declared one person for line. Then I'm going to have for my next choice only 4 possibilities left, and then 3, and then 2, and then finally 1 possibility left. So if you think about it like options, this is what I would be left with. And what I would need to do is multiply all of these options together, and that's going to end up telling me my total number of possibilities. So if I just multiply that up, I should have done this ahead of time. I think it's 720 if you do that. So I'm like 95% sure I'm correct here. If you multiply 6 times 5 times 4 times 3 times 2 times 1, that means there are actually 720 different ways you could line up 6 people. Definitely not going to be something where you'd want to write them all out. So with that kind of out of the way, I want to actually, before I go to my next example, it happens a lot in math where you take a number and you keep decreasing it and multiplying it. Like I could do 9 times 8 times 7 times 6 times 5, blah, 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 or 12 times 11 times 10. You end up multiplying like this where you go down by 1 quite a bit. There's actually a symbol for it. So what you do is you put the biggest number, and the symbol is actually an exclamation point. So this right here is not just like 6, like really excited 6. It's actually a symbol called a factorial. So you would pronounce this 6 factorial, and it means you start at 6 and you multiply all the way down to 1. That's a math symbol you might sometimes see on the ACT or, I don't know, in higher level math classes. If I have 10 factorial, it just means 10 times 9 times 8 times 7, all the way down to 1. So let's do one more example in my video here. And for this example, I have an awesome looking box right there, really detailed box with 13 marbles in it. It looks like 9 of my marbles are blue, and then I have 4 orange marbles as well. So 9 of those and 4 of those. And what's going to happen is I'm going to reach into the box, I'm going to pick out a marble, and then I'm going to go and pick out a second marble without putting the first one back. So it's going to be 2 picks, one after the other. When you do multiple picks, it will have to say with replacement or without. Without replacement means you throw away the marble, you don't put it back. If it said with replacement, you would put it back in. So they want to find the probability that both marbles are blue. So if we think about this for a second, I'm going to make 2 fractions because I'm finding probability, not just the total number of possibilities like the last 2 slides. My denominator is how many options I have. For my first marble that I pick out of that box, I have 13 options. There are 13 marbles in the box. And then once I get that marble, I kind of throw it away. So for my second option, there's only going to be 12 marbles that are left inside that box. So just like with factorials, what ended up happening right there is it went down by 1 because it was without replacement. If it would have been with replacement where I put it back, it would stay 13. So if I multiply those together, that tells me how many possibilities there are for my 2 marbles total. I just do 13 times 12. And 13 times 12 is 156. So that's going to be my total number of possibilities here. And then for my top, my first marble, I want to get blue for both. There are 9 blue marbles in that box. For my second pick, though, if I already got a blue on my first one and I throw it away, there's only going to be 8 blue marbles left. So when I actually multiply that out, I'm going to get 72 over 156, which you could go ahead and reduce or make a decimal. But last video, we talked about OR probability, how you had to add them together. When you have AND probability, I want a blue and a blue. You need both of them. And you have to multiply your probabilities together instead. So and, if you need both things, you multiply for the probabilities. So your assignment for this lesson is to make me a similar problem to this right here, where I did an AND probability where you need 2 of something to happen. Just draw your own picture. It can be a really detailed, awesome picture like mine, or it could be something a little less artistically inclined. Make me a picture, figure out a probability with 2 picks without replacements, and then just take the picture of your work and send it my way. That is our lesson on AND probability.